One of the things I wanted to do with the second year programming students is give them some more practice working with graphics. So I created a program called Java Chess Gui. And I know that some of you are using C++ for these projects. This one's going to have to be Java. So if you go inside it, the assignment description here is pretty small, but it has a link here to take you to all of the code I've written for this project. So if you click on that, it'll bring you to my GitHub repository for this, which is called Chess Gui, and it has a little bit more instruction on what the assignment is. So let's just read this together. So it says the purpose is that students will apply many of the concepts they've already learned in order to add on to my code and create a fully functional chess game. And it says current behavior of the project. The user interface is already created. There is a board and 32 pieces. Feel free to replace the piece images with your own if you'd like. The white pieces go first and then the black pieces, and they continue to take turns. The pieces can move anywhere right now. If the place they move to has a piece, that piece will be killed, even if it is the player's own piece. And then the instructions, it says, your job is to program the game logic that restricts pieces from making illegal moves. You will implement the can move method for the king, queen, bishop, knight, rook, and pawn classes. Here is what the pawns can move method looks like. So as you can see right here, we've got a method that returns a Boolean value, which is either true or false. And it takes in an integer that represents the destination x value, so where on the board they're trying to move, the x coordinate for that, and then the y coordinate for that location, which is also an integer. And the pawn has specific instructions right here. It says, remember, a pawn may only move towards the opponent's side of the board. If the pawn has not moved yet in the game, for its first move it is allowed to move 2 spaces forward. Otherwise it can only move 1 space. When not attacking, it may only move straight ahead. When attacking, it may only move 1 space diagonally forward. And then it says, write your code here. So all of this, of course, is just a comment, so you can get rid of it if you want, or you can just add on underneath here. Right now, it just returns true every time. So let's actually run that. I want you to see what this looks like. If you were to download all that code and click run, this is what the program looks like. We've got a chessboard with 32 pieces, and we've got pawns in the front. So white goes first. So I could say this pawn, let's move here. But the funny thing is, because it always returns true from that function, it really doesn't matter where I move. I could jump all the way to the king and kill the king on the first move, which of course is illegal. So you need to change it so that it follows all these rules. Okay. And the way that you can change it is by using these methods here. You can check whether there's a piece at a specific spot by using the board.getPiece method. You can check what the x value of a particular piece is by using the getX method. And the same thing with the getY method. You can check what the y coordinate of a particular piece is. And then you can also check if a particular piece is white or if a particular piece is black with these methods. Okay, so if you're wondering how to download it, just right up here, there's a little green drop down. You can say clone or download. You just click download zip. And that will give you the zipped file with all of the code in there. And if we open that up, it looks like this. So we go inside, and there's another folder with the build folder, images folder. You can actually go inside there, and these are all the images that you can change if you don't want it to just say B or P or whatever. Okay, so back into that main area. This folder right here, src, has all the source code in it, and it's in a package called Chess Gui. And then there's another package inside that package called pieces. So these are all the guys that you'll have to change, except for this one. You don't have to touch that one at all. And the only places you have to change are clearly specified. Cool thing about NetBeans is if you just open up NetBeans and go to Open Project, once you've extracted it or unzipped it or whatever you have to do, you should be able to find that folder in your downloads folder or wherever it was saved. And it's Program Your Own Chess Master. And the project should just be sitting right there, so I can open it. Anyway, so these are all the files in that project. We've got quite a few. Again, these are the only ones you have to change, the ones that say bishop, king, knight, pawn, and queen and rook. Piece, if you look at piece, this is all the code that applies to every piece. So I've already done that for you. You just have to program the specific things for each piece. And if you go inside the pawn, like I was showing you before, there's a method called canMove with this description of what it should do. If you go inside the queen, it also has a method called canMove, but the description of what it should do is different. So like I was saying, if I run this code right now, it will bring up a board with those images on it, and I can move anything anywhere at this point. I can move a bishop all the way down here to kill this pawn, because the bishop's method for canMove always returns true. In fact, that's the way it is for every piece. But now that it's black's turn, we can make black move over here and say, you just killed my pawn by jumping over some guys you shouldn't have. What if I just kill your king? See, it's not supposed to work like that, so we got to change that. So in this tutorial, I'm going to show you how to get started by implementing the Rook canMove method. So the Rook is the one that's right down here. And the Rook is allowed to move as far as it wants in a straight direction. So that could be forward, sideways, or backward. And it just can't jump over pieces, and it can't kill its own piece. So let's go into the Rooks code, and let's just start coding it up. So the first thing I want to do is make sure that wherever we're trying to move this piece, according to its destination X and destination Y, that we don't already have our own piece there. So let's just leave a little comment there to let us know what we're trying to do. And then after we write the code for that, let's write some code that makes sure that it moves in a straight line. And then we just need to make sure that there are no pieces in the way of us moving there, because the Rook is not allowed to jump over pieces. So let's leave a little note for that. So right now, if I run this code, I'm able to kill my own pieces. Like this Rook right here is able to move right next door and kill the knight, even though they're on the same team. And then black is also able to do the same thing. He can move forward and kill this pawn, even though it's his teammate. So let's fix that part first. We're trying to make sure that at our destination point, if there is a piece, it's not our own, because we don't want to be able to kill our own piece, right? So the first thing I want to do is check whether there's a piece there. And I'm going to have to use one of the methods I just talked about where we downloaded the code. I'm going to have to use the one that says getPiece. So it belongs to the board class. So the nice thing is we have a reference to the board that all of these pieces sit on. So we can use that to call the getPiece method. We can say board.getPiece at a specific X and Y value. And it's guessing destination X and destination Y, because those two variables are already part of the function. So all by itself, this isn't a very useful line of code. This function is supposed to return a piece if there is one at that place, and it will return the value null if there isn't one. So let's just create a piece object called possible piece, because it might be a piece, and we'll assign it to equal whatever that function returns. Then we can check if it equals null. We can say if possible piece does not equal null, that means there's a piece there, right? So in that case, let's check if that piece is our same color. So we can use another method where we found the code called piece.isWhite. So we just need a reference to a piece object, and then we can call isWhite on it, and it will return true if this piece at this place is white. It will return false if it's not. So let's check that. We can say possible piece dot is white, and the piece that we're trying to move there is white. Then we want to return false, right? And that'll say canMove is false. We're not allowed to move there because we don't want to kill our own piece. We're also going to have to check whether it's a black piece, and we're a black piece. And in that case, we also return false. So now let's run it and see if we're still able to use a rook to kill its own piece. So white goes first, so let's try to kill the knight that's right next to us. So I click it and it didn't move there because I told it if this is my own piece, I'm not allowed to kill it. So let's try it now with black. So let's move white. Now it's black's turn. If I tried to kill the pawn right in front of me, it's not going to let me do that either. Okay, so it looks like it works so far. Okay, the next thing we want to do is make sure that this piece can only move in a straight line. Because it's a rook, it's only allowed to move forward, backwards, or sideways, right? So right now, if we were to run it, the rook is allowed to move diagonally, right? I could say, let's move this white piece all the way over to here. See, it's not supposed to do that. So let's fix that. This is actually pretty easy. We just need to make sure that one of the x or y coordinates of our destination point matches one of our current x or y coordinates. So we could just say if our current x value does not match our destination x value, and if our current y value does not match our destination y value, then we return false. Okay, so let's run it now. And the white rook should not be allowed to move here now. See? So he's not able to move anywhere except for a straight line. So if we were to try to make him move here, he could. Now, in order to do that, he jumped over a piece, which he's not supposed to do, and that's what we'll fix next. So the last thing we have to do for this rook is make sure he's not jumping over any pieces in order to get to his destination. So first thing we have to do is find out which direction he's trying to move. And this is actually pretty easy. We can just compare the x and y values of our current position to the destination x and y values. So if our destination y value is greater than our current y value, then we know we're trying to move down because y starts at the top of the screen and gets bigger as it goes down. So if destination y is greater than this.getY, we know we're trying to move down. So let's create a little variable actually to tell which direction. And if the destination y value is less than our current y value, then we know that it's trying to go up or north. So let's assign the value of direction to be north. If the destination x value is greater than our current x value, we know that it's trying to move right. So we can give direction the value east. And then the last case is if destination x is less than our current x, we know we're trying to move to the west. So we'll set direction to equal west. Okay, so now we just need to make sure that whichever direction it's trying to move, there are no pieces in the way because it's not allowed to jump over anything. So this is the trickiest part for the rook. And we're going to have to do something different depending on which direction it's trying to move. So let's handle the case where it's trying to move down first. So we say if direction dot equals south. And we're going to have to do a loop and check every position from our current position to our destination position and make sure that everything in between those spots is vacant. So the first thing we have to know is how far are we trying to move. So let's say int spaces to move, and we're going to set it equal to the absolute value of destination y minus our current y. And that will give us the distance between these two spaces. And then we can set up a for loop. So in a standard for loop, you'd start your I at 0, you'd go while I is less than the spaces to move, or the however many times you want it to repeat. And you have I increase every time. And what we're going to do here is we're going to check each of these spaces to see if there's a possible piece there. So let's say piece P equals board dot get piece. And in this case where we're trying to move down, our x value is going to be the exact same, right? But our y value is going to utilize our iterator I. So let's say this dot get y plus I, because as we go down, y increases. So when this for loop starts, I equals 0, so it's going to say, hey, give me the piece, if there is any, at the space that has my same x value and my same y value plus 0, which is the space I'm currently occupying. And as I increases, it's going to keep checking beyond that, and it's going to go all the way to the destination space we're trying to move. And for each of those spaces, we want to check if there's a piece there. So we're going to say if p does not equal null, that means it's occupied, right? And we're not allowed to jump over anything, so we're just going to return false. However, as I just pointed out, with I starting at 0, it's going to start at the space we're currently occupying, and it's going to say, there's a piece there. You're not allowed to jump over it. So rather than start at 0, let's just have it start at 1. Okay, so let's run this and make sure that we're not able to jump over any pieces when we're moving a rook down. So let's just play around with the board a little bit. So if I were to try to move the rook right here, I'm able to do it, right? And now it's my turn again. If I were to try to move my rook here, I'm going to be jumping over the pawn, which I'm not allowed to do. So it doesn't let me do it. So far, so good. So let's move him back there. Of course, the black rook is still able to jump over this guy because that's moving north. We haven't accounted for that case yet. But if we were to try to move him back down south and jump over a piece, he's not able to. Okay? So now that we've got it working for one direction, it's really easy to make it work for all the other 3 directions. We can just copy and paste the code and change it according to each direction. So let's say if direction equals north, then we're still checking our change in y, so we can leave that the same. And we're still going to be moving that many spaces. But what changes here is instead of adding I every time, we're going to subtract I because we're moving up instead of down. And the y value increases as we go down the board. Okay, so that should work for north. And if we're moving east, which is to the right, we're going to be moving on the x-axis. So instead of checking the y displacement, let's check our x displacement. And this part can stay the same, but here we want to add I to our x value rather than our y value. And then if we're moving to the west, we're moving to the left. So we're still looking at the displacement in x, so this is still good. But what needs to change here is instead of moving to the right, we're moving to the left, so we subtract I for each iteration. Okay, and that should do it. If we were to run this program now, the rook should be fully functional. So let's test it out. Let's try to break it and see if there are any bugs with the rook. So first thing I'm going to do is I'm going to try to jump over the piece here. Can't do it. Good. So let's move this guy up. Let's move this guy up. Let's try to jump on him. Can't do that. We can still move there. That's good. Let's move that guy forward. And let's try to make this guy jump over here now. We shouldn't be able to. Good. Let's just mix up the board a little bit and see if we can do some interesting things. Okay, so I'm going to try to jump over this pawn here to the left, and it won't let me do it. Okay, let's move it so this guy is under us. See if we can jump over him. Can't do it. Good. Now let's move him to the right of us and see if we can jump over him. Good. Can't do it. Now let's move so that he's above us. And let's see if we can jump over him to the north, which we can't. So all 4 directions work. Now let's make sure that we can still move forward and kill a piece. So let's try to move down here. We can. Good. If I wanted to move here, I could. If I wanted to move here, I could. If I wanted to move right in front of the king, put him in check, I could. And I could even jump down here and kill him. So the rook is fully functional, and I hope that helps you get started with the other pieces. There's a lot that goes into this, but if you break it apart piece by piece, step by step, like we just did here, and solve a bunch of smaller problems, it'll make this a lot easier. So If you have questions, of course, that's what class time is for, so good luck.